This is the homework for lesson number 92, the PIO toggle switch. Paul McWhorter wanted us to do a push button that allows um, the count to count up in binary to 15, then back to 0. If you look down here, you'll see I got the Raspberry Pi Pico. I have a bar graph for the LEDs. It's a lot easier to deal with those. And then I put 10K resistors in series with them to kind of keep the glare down. I'm using the green button for this software. The red button is not being used. Now if I go to the software, you can come over here and you can see where I've imported time, machine, port pin, and import to RP2, which is the state machines library. Now here's a decorator. Paul set this up several times, and I had a hard time with this because I left that little underscore out, and it was driving me crazy because it looked perfect, and I couldn't see why it wasn't working. But anyway, I finally got that fixed. And then come down here, you've got what do you call that thing? You know, every time I go to this one here, I have a problem with what it's called. But anyway, it's part of that. It's part of setting up the state machine. In this case, we set up state machine 0. We set up a weight pin low, and then we use the base pin 14 in base pin 14. So, and then we set it as pin input, pin pull down. Then we set the frequency, and then the out pin base is 16, and that goes 16, 17, 18, and 19 for the LEDs. In this case, the LEDs are 16, 17, 18, and 19. Now, in the software, I come up here and I set up the definition that's going to go to the wrap target, and the wrap is here. I set the X register to 1111, and then I set up a label for loop and wait for the pin. And I noticed if you set this as 1 and this one at 0, you get a whole button push before it activates. So I switched it around, and as I push the button, it activates on the upswing. If you notice, as soon as I let go, it starts to go. What was happening is I was going down, and I was getting a whole cycle before it would start counting. Now, if you look here, we wait for pin 0, wait for a pin 0 at pin 0, which is 16, or in this case 14. And then we do a little wait for debounce. Then we move. I had to use the Y register. I was trying to do it with just the X, but apparently you can't. So anyway, I had to invert the X and just push it into the Y, or put it into the Y. Then I had to move the Y register to the pins. That works pretty good. But I was trying to figure out some way to do it without the Y register, and I couldn't. Anyway, we have to do another wait down here. So when the trigger, when I let go of the button, it knows what to do, and it comes down through here, gets debounced, and goes back up to loop. So it goes back up to loop and skips this guy. And then as it decrements as it goes up to the loop, and as that decrements, the Y actually increments, because you're taking X invert and put it in Y, and then Y is now If it's 1, 1, 1, 1, 0, this is the y is 0, 0, 0, 0. Okay, if you now let's go through what is going on here? What keeps it? Okay, and I go through and I'm 7, 8, 9, 10, 11, 12, 13, 14, 15, and back to 0. All right, there's my homework, and I appreciate you doing all these videos, Paul. Sure, these are sure interesting because I can see what this would be real useful with using Python and put this stuff in the background, and you don't have to worry about it other than to send things and pull things back out. Anyway, that's my homework, and we'll see you guys on Thursday.